Okay, welcome back, and we'll try question 4 from the stats paper now. So part A of this is really straightforward. We just need to set up a binomial model and use that to calculate the probability of exactly 5 white plants. And then our second question has a little bit more ambiguity. Let's go ahead and do part A, and then we'll talk about part B later. For a particular plant, 45% have white flowers. So I'm going to let W be the number of white flowers. And W can be modeled using a binomial. So W can be modeled as a binomial with 12 in the sample, and that's the number of things, and a probability of success of 0.45. So the probability that W will equal 5 is something that we can use on the calculator using the binomial function. And we can just look that up. Using the calculator gives us 0.2225 to 4 decimal places, which is an appropriate level of accuracy. There's our answer for A. For B, we need more white than coloured flowers. So out of 12, that is 7. So we're looking for the probability that white is greater than or equal to 7. Calculator can't do that, so we need to do 1 minus the probability that white is less than or equal to 6. And again, we can go to the calculator to work that out. It gives me 1 minus 0.7393, which is 0.2607. So far, this has been straightforward, and we should be pretty happy that we've got 4 marks on this. This part all uses a binomial model. However, if we look at the second question, part C, if we look at part C, it states that we must use a suitable approximation. So we must change from using the binomial to using the normal. And in doing so, that means that we have to calculate for any normal distribution, we need to know mu, and mu is equal to NP. We also need to know sigma, sigma squared, that is equal to NP times 1 minus P. If we work out NP, that's 12 times 0.45, but we're selling in batches of 50, an additional change, we're selling in batches of 50, so we're going to do 50 times 0.45. So we're going to see this mu is 50 times 0.45, which is 22.5. That's the mean, and sigma squared will be 50 times 0.45 times 0.55, and that will come to 12.375. Cool. So overall, that means that we can now rewrite our binomial as a normal distribution. So we're going to need to create a new binomial here, and let's give that a new letter. Let's call it W. Let's call it V. V can be modeled as a binomial with 50 trials and a probability of success of 0.45. V is approximately equal to X, where X is a normal distribution with 22.5 as the mean and 12.375 as the variance. Now we want to use this to calculate the probability that there are more than 25 white flowered plants. So we want the probability that V is greater than or equal to 25. No, strictly greater than. So not greater than or equal to, strictly greater than. Let's erase the mistake and carry on. And that will be approximately equal to the probability that X is greater than 25.5. We need that half point correction error. And we can do that directly on the calculator now using the normal distribution, normal CD, and that gives us 0.1969. That is worth 7 marks. The marks are for working out these things, for correctly identifying your model, and for getting your final answer. Let me know or talk to a member of staff if there's another member of the maths staff if anything there is not clear.